Hello, in this video we will learn how to create functions in Swift and use parameters and arguments. We'll also go over the importance of abstraction and how to use argument labels. So let's start. To create a function in Swift, we have to use func, and then for this task we have to create a function called introduce myself. So func introduce myself, um, and then we use parentheses, and then we use curly brackets. So this is the basic syntax of creating a function. And now we just have to create a print statement that gives a quick introduction of ourselves. So print, and then double quotes, I love programming in Swift and love making mobile apps. I also like playing chess. So now let's see what happens when we call our function. So to call the function, we just do we just type the name of the function. So introduce myself, and then there should be parentheses after it. Just like how we initialized it. So now we can see that it prints what we wrote inside the function. And functions essentially help us make our code more efficient and allow us to run in nonlinear time. So let's go over to the next task. Write a function called magic 8 ball. So write a function, and we're going to write func, and then name of the function, and then parentheses, and then curly brackets. So this function has to use if or else statements to create a custom response based on the number generated, and we will create a constant named random, and it will be equal to a random integer between 0 and 4. And now, depending on what random is, so if, let's say, um, if random is equal to 4, then we would print, let's say, it is 4. And else if random is equal to 3, we can print same thing, but it is 3. So now we can use this for all other cases, and one more time, I believe. Okay, so now if it's 2, we do that. If it's 1, we do that. And if it's 0, we use that. And let's say it's 3, it is 2, it is 1, and it is 0. So let's now call a function and see what happens. Magic 8 ball. Okay, so it seems. Oh, so we have to use double equation marks to show to test if it's equal or not. And okay, so we got 3 this time. Let's run it again. We got 2, we got 4. So it works. So in this case, we're calling the function in the same way we call the function here, and there are no parameters. But let's see what happens in the case when there are parameters. So our next task would be using functions that are key. Okay, so we have to make we're creating a function for a fitness tracking app, and it looks like we have to create a function called increment steps, and after declaration of steps below it'll increment the steps by 1 and then print its value. Call the function multiple times and observe the printouts. So first let's create the function. So it's func, and then func, and then we're going to type the name of our function, parentheses, curly brackets, and now we're going to see it's going to write a function, and it will increment the steps by 1. So to increment it, we do steps plus equal to 1. So that increments the value of steps by 1. And let's print the value of steps. So let's print steps. And let's call the function to see what happens. So let's do increment steps. So we got 1. And okay, so now after the and it will increment the steps by 1, and then it's print its value. So each time is equal to 1, and then it will do that. So After the declaration steps below, call the function. So when we update it, we get 1 because every time it reruns the whole code, and we're declaring it as 0 before we do this. That will increment steps by 1 and then print the value and call the function multiple times and observe the printouts. Similarly, if you want to regularly provide progress updates to a user, we can control flow statements to check on progress into a function. So our function would be called progress update. So func progress update and curly brackets. And then the functions print you're off to a good start if steps is less than 10% of the goal. Okay, so if steps is less than 10% of the goal. So 10% of the goal is, I believe that's 10,000 divided by 10. So if it's less than 10%, um, then we print you're off to a good start. Now, let's say if it's less than half of the goal, so else if steps is less than, this time, 10,000 divided by 50. So if it's less than uh, half of the goal, sorry, less than 2 divided by 2. So if it's less than half of the goal, we will print you're over halfway there. And now if it's less than 90% of the goal, so else if steps is less than 90% of the goal, which is 10,000 times 0.90, so that's 90%, then we could do you're almost there. Okay, so then we could just essentially initialize this as 9,000. And for here, we could do the same thing, but we could use the goal and goal. And now if it's and if it's beat your goal otherwise, so else print you beat your goal. Okay, so let's run and see. Now we have to call the function. So progress update. So you're off to a good start. So if number of steps is less than goal divided by 10, print you're off to a good start, and our steps are less than and our steps are essentially 1. Let's go to the next exercise. So in this exercise, we have to create a new function called introduction. So func introduction, and it should take 2 string parameters, name and home. So now we're getting to parameters. So parameters are essentially ways to essentially, I guess, customize or make your function do stuff based on certain inputs. So to the syntax of a parameter is, let's say we have the parameter name, so we type name and then the type, so it's a string. And we use a comma if there's multiple, so next one is home, and then we use a colon and the type, so string. That's the same thing. And before we just had parentheses, now inside the parentheses we declare the parameters. And then, and another parameter called int. So we do another comma, and then this time it should be called age, and then int. Function should print a brief introduction, i.e., Mary, California, 32. We're passing the function. I print Mary, 32 is from California. Call the function and observe the printout. So this time let's do print, and let's say we need to print first the name. So we do name, and we use the same variable we declared here. So name, and plus let's actually add a comma and a space. And now we're going to add that's actually another way to do it. We could essentially put all of this inside double quotes, and now we could say using escape, we could use the parentheses and then type in name, so the variable name, and then we could act like it's part of the string, and now comma space, and then again backslash parentheses age in, and then comma is from, and backslash parentheses location home. So let's call our function in production. And for the string, I'll say, so for the name, I'm gonna make one up. I'll say um, um, Jack. And then for the string, we could say New York, and then int 25. Now we can see that it prints Jack, 25 is from New York. Now we're going to write another function, so func named, called almost addition. And this time it takes two integer arguments, so parentheses, the first argument should not require an argument label. The function should add two arguments together and subtract 2. So here we'll get into argument labels. Here we'll get into argument labels. Essentially, argument labels are something you add before the parameter name. Let's see an example. So here we need two integers. We can name this int 1, or we'll just say 1. And then the argument label is essentially the external parameter name. So it could be called 1 outside. And then now the internal parameter name could be number 1. And we could, next we say the type, so it's an int, comma, so another one. So we could say 2, and then number 2. And now we'll initialize the type for this one too. And then the function should add the two arguments together, subtract 2, and print the result. So now we're going to use curly brackets, and then we have to add the two arguments together. So we're going to print number 1 plus number, let me also use number here, number 2. And so we're going to first add these two numbers together, and then we're going to subtract 2, and now we're printing the result. And let's call the function, so almost addition. And the first one would be, let's say we do 10, and then we could say 30. So here you can see it adds the two numbers and then subtracts 2. So argument labels are, for example, 1 in this case, and it's like an external parameter, and you can use that when you need like an external parameter and then like a different internal parameter, so it's easier to maintain, keep track of what variables you're using, and it helpful in some cases to be more readable for the user. So the first argument should not require an argument label. So we can remove an argument label. So we can remove 1 here, and then remove 2 here. So now it's just like before, but here we would need to say 1, and now we could just do almost addition, and we could do number 1 and number 2. So in this case, the first argument should not require an argument label. So we do not want to say number 1 every time it calls it. To do that, we would use an underscore before it and space. Now we can remove the argument label, and when we call this, it won't require an argument label. So it still performs, so the function still works correctly, and we haven't provided an argument label. That's because we added the underscore. Next, we write a function called multiply. So function multiply, and it takes two double arguments. So we could say, so the function should multiply the two arguments and print. The first argument should not require a label. The second should have an external label by. So since it should not require a label, we put an underscore, and then we can name this double one. And then the type would be double. Next, it has to have an external label by. So we could say by, and this time double two, and the type is a double. So let's use curly brackets, and the function should multiply the two arguments and print the result. So we'll print double one times double double two. And now the reason the argument labels are differing is because the first one we use the underscore, so um, we don't have to say double one, and so we just name it. We could say 3.5. But the second one, it has a argument label, and it's called by. It's the external label. So we would have to say by, and the value of double could be something like 4.7. And now it multiplies the two numbers together. So next, we would have to create a similar function to what we did before regarding progress update. But this time we're giving it two parameters, a type int for steps and a type int for goals. Let's see how we would do that. So first, let's create the function. Control Z. So first, let's create the function, and it's going to be called progress update. And now we would need to have it. We would need it to have two parameters. The first one is a type int called steps. So we say steps, and we initialize the type int, and comma for another parameter, and this is called goal, and this is also int. And this function, like before, should print you're off to a good start if steps is less than 10%, and so on. And we can actually reuse the same code from an initial function. So if we'll copy that part, and now we'll paste it here. But there are some differences. So for example, it takes in the goal, and the steps is the same variable, and but the goal here could be different. So here we would have to do goal and divided by. So if steps is less than 90% of the goal, so that would be around divided by 9. Well, it divided by 10 and then times 9 times 9. Or I could do goal times 9 divided by 10. That would be 90% of goal. And it's func. Okay. So let's run our code and see what happens. Yes, we also have to call the function. So let's do progress update. And then number of steps, we could say 6,000 as an example. Our goal could be 10,000 steps. So we should essentially be over halfway there. Let's see what it says. Should run. Oh, okay, we don't have a print statement here. We figured that out. Okay. Great. Okay. We can remove this for now. Let's continue. So your fitness tracking app is going to help runners stay on pace to reach their goals. Write a function called pacing that takes 4 double arguments called these stuff, and then your function should calculate whether or not the user is on pace to hit the goal, beat goal time. If yes, print keep it up. Otherwise, you gotta push it just a bit harder. So let's create a function. We'll name it func, and then specify what we should name it. Didn't say what we should name it. And so let's say pacer. We can name it pacer, and it should take in 4 doubles. So let's call the first one current distance. So current distance is a double. Goal distance is a double, and then current time is also a double. Goal time is also a double. Okay, and the function should calculate whether or not the user is on pace to hit or beat goal time. So to do that, we would essentially have to figure out what pace they should be, and then if they're on, if whether they're on or above the pace or below the pace. So we would print. So firstly, if they're on, the pace is equal to or greater than the pace they should be on. So to calculate that the pace they should be on, it would be total distance divided by goal. So total distance, for example, write a function that takes 40 minutes. So current distance and then total distance, and then current time and then goal time. Okay, so the total distance is, let's say, 5 miles, and then the goal time would be in 5 minutes. And that's not realistic, but 5 minutes is easy to math. And if the current distance is 3, um, essentially the ratio should be greater. So we can do total. We can do if total distance divided by goal time is greater than current distance. Let's see what happens. Current distance divided by current current time, and we also need to make it equal to. So we could do greater than or um, equal to or greater than. And now we would need to, I think it goes after. Okay, so we would need to print your keep it up. So we print keep it up, or else you've got to push it a bit harder. So I just realized I've switched this, so this actually should go here, and that actually should go here. And the logic behind that is that the essentially that we are calculating what the current pace is, so current distance divided by current time, and we're checking if their current pace is greater than or equal to the pace they should be. So let's call this function pacer, and let's give an example. So we could say there are 5 miles, and the total they're at 5 minutes, 5 miles, and then okay, I realize I named these two things the same thing. This should be total. It should be current distance, total distance. So current distance could be total distance could be 10, current distance 5, current time could be 6 minutes, total goal time would be 10 minutes. So uh they should be on their pace, and we would have to print these. Okay. Okay, you gotta push a bit harder. So the current distance is so see they're overtime. So if you do 4, that's good. They're on time. So yeah, this one is very interesting, and I believe we have covered most of the basics here. Let's go into a bit more examples. So we have to write a function called greeting, and it is called greeting, and that takes in a string argument called name. So name type is string, and then it returns a string that greets the name that was passed in the function, i.e., if you pass in Dan, it return the value might be Dan. However, I used the function with the result. This is fairly simple, so we could do print backslash parentheses. Actually, before that, we would actually do hi, and then parentheses. Okay, and then we would write name. So hi name, a comma after the hi, and then we could say how are you. Now let's do greeting John. So this is say hi John, how are you? Okay, there's extra double quote there. Hi John, how are you? So it works. Now write another function that takes in two integer arguments, and so the function should multiply two arguments, add two, and then return the result. Use the function and print the result. So we could do function. Essentially, it should return the result. So we should have this as a return, and then we would need to print what we would get. It should essentially be the same thing unless unexpected non-void return value in void function. Okay, so I guess it could be based off that way. Oh, so since we have it as a non-void, so as a void function, it shouldn't have a return. Okay, so function, and now we're going to call it, I guess, multiply add 2, and we're going to say num1, it's the integer, num2 is the integer, and now we're multiplying two numbers, so we're going to print num1 times num2, and then we're going to add 2 to the result. Now let's call our function multiply add, would have 9 and then 10, so it should be around 92, and print the result. Okay, let's go on to our next exercise. So for this exercise, we would need to write a function that only does a portion of what a previous pacing function did. This function we call calculate pace, and should take three double arguments: current distance, total distance, current time, and it should return a double that will represent the time at which the user will finish the run based on the user's current distance and current time. Call the function and print the return value. Okay, so the function should be called calculate pace. It essentially calculates the time, taking three double values. So this is one value, and it'll take another double value. It'll take in another one called current time. And now we are going to calculate the user's pace. So firstly, let's just say let pace is the constant. We're gonna let pace equals current time divided by let's do current distance. So let's say it's 5 miles, and then current time. So it'll give us a ratio, and it's a 1 to 1. So let's say if they ran 10 miles and it took them 20 minutes, it'll give us 1/2. So basically every 1 mile it would take them 2 minutes. And now it will represent the time at which the user will finish the run based on the user's current distance and time. So we'll take total distance. So this is the rate at which they're traveling. So we're just going to take total distance, and we're going to print the value. So let's assume now they're at 20, we would divide the total distance by the rate at which they're going. So we could print total distance divided by the pace. Now let's call our function calculate pace. Let's give examples. Current distance, let's say they ran 5 miles. Total distance is 10 miles. The current time in 10 minutes, so you should take them double the time, so 20 minutes. Okay, that seems to be working. Now I have a function called pacing that takes 4 double arguments. The function also return a string that will message the user. And okay, I believe this is essentially the same thing we did over here. Let's Uh, okay, but they said name it this time, so we will name it. So pace. So pacing. It takes in four double arguments like before, called current distance, total distance, current time, goal time. The function will also return a string, which will be the message to show the user. The function should call calculate pace. Function should call calculate pace. So it should call calculate pace. So to do that, I guess pass in the appropriate values and capture the return value. The function should then be compared to the return value to goal time. And then if the user's on pace, keep up and return we got to push a bit harder, otherwise call okay. Okay, so to be able to return specific values rather than print statements, we would need to use a, I guess, line and then a greater than sign and then the type it will return. So this one will return a double. Now we could just say, instead of print statements, return the value of that, and we're gonna print what we get. So it should work the same way, and we should get 20. Great, okay. And now we would need to, now we're going to call calculate pace. So let's see, let's call calculate pace over here. Calculate pace. And the current distance will be current distance. Double will be total. It will be total distance. Current time will be current time. And if that's greater than, okay, so this will also return a double. And now, so if that's their pace, so it gives us the time that they will take, that they're projected to finish. So if the time that they're projected to finish is less than or equal to their goal time, and so if it's less than or equal to the goal time, then it should be keep it up, or else we would have to call, else we're gonna return, you just gotta push a bit harder. So let's return this. Okay. And missing return, okay, so cannot convert return type of string to double, so the return type here would actually be a string. Let's see what it returns, and let's print what we get as it returns. We get keep it up, so that's good. And we'll do the same thing, so use the function and print the result, and the return value might be, so we're going to return the string value, and now we're going to print the value. And now we do the same thing, but this time it returns an integer. And now we could do return that integer, we'll print what it returns. It seems, okay, we still have the leftover parentheses. Okay, yep, that seems to be working. I believe it takes some time for these errors to go away. Okay, let's go over here too. And then if yes, print, otherwise you got to push hard. So I think we're still printing here. And then call the function and observe the printout. So we're still printing. Let's see if we're still printing here. Call the function. And the function observe the printout. So okay. So we'll start returning from now. And where are the two errors? So they are here. Okay. Expected expression. Okay, so it seems errors are gone. We can close the side panel. And that's it for this exercise. And to recap, we have learned how to create functions, what are argument labels, and how to utilize parameters. Check out the full playlist for the full Swift course.